nice to meet you all. I've been heavily involved in hardware security and software security for many years, but primarily in the mobile phone world, and now also in the IoT space and the automotive space as well. So we have a project which is called TAIBOM, which is essentially a trusted AI bill of materials. So we've just been talking about it in one of the breakout sessions. The concept of a software bill of materials is not new, and certainly if you're a US-based company, there was a Biden executive order a couple of years ago that essentially mandates it in the USA. So US companies know it well, but what I found in Europe, actually, some companies have not even heard about it at all, and the companies that have heard about it are scared of it. So what a software bill of materials does is essentially, outline exactly what the recipe is, what is in that piece of software, including all the dependencies and the open source requirements and so on. And a lot of the factors driving this were about security. And so there were a few incidents where certain software libraries were not even known to be in software, and that then became a critical problem, became critical security problems very, very, very quickly. And that, I think, coalesced opinion in terms of, okay, we need to come together to create standards to actually be able to describe what's in software. And then for us to be able to use that internally, but also potentially to be able to exchange that with partners, exchange that with companies that are requesting that as part of security compliance and so on, and also, essentially to be able to quickly respond to security issues. So we're looking at the next step of that, and a number of people are looking at this around the world. So particularly around, how do we actually engineer AI systems that are trustworthy? So at the moment, we just had this conversation that actually we don't even know what an AI system can do, it's not necessarily deterministic. It's not necessarily repeatable. So certainly from a forensics point of view, that's very dangerous. From a safety point of view, it's equally as dangerous. And there's a sort of bunch of requirements that come together that lead to us needing to have what we would call this TAIBOM, this trusted AI bill of materials. So in a traditional SBOM, you're essentially describing the software, and then you can digitally sign that. So you can write it out in a structured format, in a standardized format, and then you can say, this is exactly what's in there. And then if that changes at any point, you can actually say, well, that's not the original piece of software. And so we can apply that to AI as well. If you think about an AI system that's running, and especially if it's running locally, it still has to have a set of files that live on the file system. So that's essentially, fulfilling the requirements for a software bill of materials. But I have to put my glasses on, I'm sorry. I'm getting old. So the very basics of what we need as businesses, if we're to deploy AI in our products, is the component pieces of that system. And that includes the data sets as well. So the data sets are often very, very poor. It's an area that we really need to improve upon, actually the creation of the data sets, but also in the usage of them. And that's even before we get to kind of, why. And the reason why is because if I choose as an external attacker to poison that data set, which may be actually pulled in regularly and never ever checked, thousands, potentially millions of items in there, we can start to subvert the AI system quite easily. So we need to know their provenance as well. So what we mean by that is, the origin, we can actually certify against that and say, whether it's for international supply chain requirements, but actually just be able to know where to go back to as well. It can allow us to apply greater weight to inputs, for example, to AI. and have more confidence in it. And we need to make sure that they're immutable. So that's the non-changeable element of it. So we're assuring the integrity, at least at the point at which it's digitally signed in the first place. So what are we doing? Well, we have this Innovate UK project, and it's brought together a bunch of companies and organisations, including TechWorks. And there's two key elements to this, which is about the creation of the standard. So we're going to define and ensure those properties of a complete and complex AI system, and therefore we can actually make a statement to say that's a stable AI system. And that's quite useful in the automotive world as well. And then we're going to create a method of making and evaluating claims about the trustworthiness and the attributes of a stable AI system and the parts that are in it. So there are two elements there. We're going to create a standard, the Trusted AI Bill of Materials standard, so how to describe it. And then we'll also be providing a suite of tools that companies can use to actually make this easy for them. What we have is two key elements to this, which are the left-hand side, which is the Innovate UK project partners. And you can see we've got some quite large and influential organisations, and then we've got Copper Horse. And then I keep looking at this, there's nothing there. But that's really quite tight. We're a third of the way through the project now, which is a year long, so we're quite aggressively going after that. Our part in the project, by the way, is actually, so we're security specialists, but we're creating the test applications, so the models. And I'll tell you a little bit more about that in a second. And then we're going to start to attack the TAIBOM as well. So we want to know, once we've got a TAIBOM in place, well, clearly attackers aren't going to stop doing anything to it, so we'll look at what we need to do next after that. But equally, so TechWorks' key role in this is creating that community and creating potentially a broader scope to evolve the standard at a slightly slower pace and to really, bring together a community of companies to contribute and to lead that into the future. So it's not going to end after 1 year, and we've already started that process. So there's a group under the TechWorks AI organisation that's been set up, and you can join that and get involved right now, and that will run alongside our work as we work on the project. So some of you might have seen the sim rig outside. That actually started off as an Innovate UK project in the pandemic, together with Siraj and a couple of other colleagues. We've evolved that, and we use that as a research platform. So when we were thinking about the test applications for the AI, we thought, well, we may as well use it. We're also working with National Highways, with Cyber Futures, with Amir and colleagues, and Max. So what we've got here, so we've taken a different tack to other companies, and I know we've got people like RF Pro and some of the big simulator companies in the room. Most of the stuff we want to do is just test stuff out and actually just research. So, for example, criminal equipment that we buy and we want to use. So, one of the simulators that we actually use is Euro Truck Simulator, which is bizarrely one of the top games on Steam. But it's great because it has massive amounts of telemetry that come out of it, and we push that telemetry into our rig, which has a CAN bus on it. But there's a huge modding community around the world, and that's actually really useful for us. So we can draw on that community. So this is something called ProMods here. This is so who actually knows where this is? Does anybody know where this is? Newport. Who said Newport? How do you know it's Newport? Yeah, you've driven through it. Yeah, you recognise it. So this is quite good. You actually recognise the places where you're going through. So this is the Bringlass Tunnels in Newport. You might not have seen that sign before. But so what we thought was a good use case, a good small application that we can build some AI around, was a small vision system that could recognise signs that were tampered with. So starting off with visual signs, so things like a 60-mile-an-hour limit, but perhaps moving forward to text. And then use that as a kind of input to existing ADAS. And it serves as a quite good demonstrator for us. So we have the rig, we have the simulator, so we can just push people into that. And then actually we can show people exactly what you mean by dataset poisoning, for example, or model inversion. It doesn't mean anything to anybody, but what we can actually do is say, this is what happens when we poison the dataset. And your ADAS starts to think that this hacked street sign is actually legitimate. So I think that's quite a good use case. If there's any history fans in here, one of our other use cases on looking at early modern shorthand from the 1600s. No? So we're good. It is my interest. So we'll be also doing a model around that as well and deciphering old codes, which is quite interesting. There's another example there, actually. You can see we've spray painted over the 20-mile-an-hour speed limit going into the Sainsbury's in Newport there. If you go to Wales at the moment, nearly every 20-mile-an-hour speed limit sign is spray painted over. It's quite impressive. I shouldn't say impressive, should I? I'll continue using that. But what we're seeing is this kind of human pushback against the system, right? And so you'll see out there, I've got a couple of examples. Number plate flippers to get around ULEZ. Fake leaves that are controlled by an electromagnet to cover up your number plate. So the automated systems are now being subverted by humans who are putting in systems to actually subvert that, and quite cheaply. So you can bet your bottom dollar that they'll try to subvert AI-based systems as well in quite straightforward ways. So we need to be ready for that. So that's really what our interest is. And if you're interested in talking about TAIBOM, we have John at the back and also Gareth as well. Talk to anyone from TechWorks and myself, of course, to get involved. So thanks very much.